Hey, welcome to math class today. Here's your lesson goal or your big idea. Today you're going to learn to solve whole number addition equations, trying to solve for the letter or the variable that's missing. Write this down with today's date, page number in your notebook, and continue on when you're ready. Here's the warm-up for today. 4 problems. They should look like your previous lesson. So go ahead and solve each problem. Put the number in for x and see if it equals. Come back when you're done. Alright, so what I did is I replaced x with the number that it was given, the value, and now we just have to see if it all equals out. So when you add 86 and 16, you get 102. So this one is a yes. It does work. 102 equals 102. For the next one, when you add 18 and 4, you get 22. 22 does not equal 26, so for number 2, the answer is no. For number 3, 168 and 46 gives you 214, which does equal 214. So number 3 is a yes as well. And for number 4, this does come out to be 35, which is the same as the other side, so yes, it does work. So the only one that did not work right would be number 2. The other 3 were all solutions. If you got all 4 right, I want you to go yippee! So let's look at this scenario. It says some surfers recommend that the length of a beginner's surfboard be 14 inches longer than their height. That's interesting. I don't even know how tall I am in inches. Well, if a surfboard is 82 inches, how tall should the surfer be to ride it? Well, you could create an expression or an equation to try to solve this. And if you took the height of the surfer combined with the 14 inches, it's going to have to equal 82. So here we're looking at having some sort of variable. We could use h for height of the person. And we take that plus 14, that's going to equal 82. Well, now that you have a equation, h plus 14 equals 82, you can work to try to find out what that h equals. And that's what we're going to work with today, is how to take a scenario like this and solve for h. Now the difference between last lesson and this lesson is last lesson I told you, or the book told you, what h equals. You don't get that anymore. Now you actually have to solve for it. Nothing to write down here. We're going to move on. So here is the scenario we're looking at with the surfer dude. So what we want to do is we want to be able to get a balanced scale where h plus 14 is going to be the same value as the other side, which is 82. So what are we trying to do? We're trying to find out what h equals. So how do we do that? Well, what you're going to be using is this process called inverse operation. Go ahead and write down this definition. Inverse operation means to undo each other. That's really all you have to write down. You could write down the rest, though, if you want. Good coffee. I put that on the video. So, what does that mean? Well, inverse operation means opposite of or undo each other. So the inverse operations are addition to subtraction. That would be one inverse operation. Subtraction to addition. That would be another inverse operation. If you think about multiplication, multiplication to division would be an inverse operation, and the opposite of that would be division to multiplication. So when you see one operation, you do the opposite. So if we go back to our problem where we have h plus 14 equals 82, the inverse operation of addition would be subtraction. So what do? Well, in this scenario, we're going to want to take that 14 we have on the one side, and we're going to want to subtract it away from both sides. Now, why do we do both sides? It's the same as when you learned how to do equivalent fractions. What you do to the top, you do to the bottom, as you learn in fractions. Well, same with our operations here. What we do to one side, we do to the other. And the reason is, if you're going to subtract 14, you got to show where you're getting it from. So after you subtract 14 from 82, you find out that h equals 68. So a person who's going to have an 82-inch surfboard is probably 68 inches tall. The easiest way to check your work, go back to your original problem and put 68 in here for our variable of h. And 68 plus 14 does indeed equal 82, so we found a way to make it balanced. Once you got these notes written down, you continue on, and we're going to do some practice problems using this new skill we learned. All right, so let's put together a practice problem that we can put into our notes. You're basically going to be copying down what I'm doing here on the board and what I already have written up here. So let's say you were given this problem. X plus 87 equals 152. So the first thing you're saying is, all right, I got to solve for X. And the first thing you're going to look at is what symbol you have between the variable and 87, and that is addition. So then from there, you know that what you're going to have to do is use inverse operation. So the inverse operation of addition is, that's right, subtraction. So what we're going to have to do here is we're going to rewrite the original problem. That's your first step. So hopefully you're doing that in your notebook now. And what we're going to do is we're going to subtract that value of 87 from both sides. So when we subtract it with the side with the x, 87 minus 87 gives you a big fat 0. It's gone. But where did it go? Well, if you ever seen the movie Charlie and the Chocolate Factory, or Willy Wonka, I forget the name of it, and you watch the little boy in little pieces pixelated above you, and he's a little cowboy kid, and all of a sudden he shows up on the other side in the screen, that's exactly what happens. So this little 87 has just been going, whoa, where are we going? And then it lands over here with the subtraction symbol and everything. So what do you do then? You subtract 87 from 152. And when you subtract 87 from 152, we're going to get x, this is our third step, x equals 65. So our answer is 65. Now how do we check to make sure it works? Just like I said in the last problem we did, put 65 into x, into our original problem, and do 65 plus 87. If we get a balanced scale where 152 is on both sides, which we do, you know the correct answer is 65. Make sure you have that written down. Again, if you need to watch this again, please do so. All right, so I'm going to encourage you to look at this problem with me and write this one down as well. So we have a different problem, but same operation. It says 72 equals 18 plus y. So again, we have to find out what y. So again, we're going to use inverse operation, which means we're going to see that we have addition here, and we're going to have to do the opposite of addition, which is subtraction. So first step, rewrite the problem. Second step, determine the inverse operation. And the inverse operation of addition, or the opposite of addition, is subtraction. This is how we undo the number we have here. And what we do to one side, we do to the other. So to both sides, we're going to subtract 18. So what does that leave us on the right-hand side? That leaves us just y. That's all that's left over. So bring her down, and you get y equals. On the other side, we're subtracting 18 from 72. 72 minus 18 gets you 54. So our answer is y equals 54. Again, how do we check that? Put 54 down here in for y, the original problem, 18 plus 54, and if that equals 72, which it does, both sides are balanced, therefore we have the correct answer. So what does y equal? Y equals 54. And we need to know that so that we can get the values to be equal on both sides. So let's take a look at a word problem. I like word problems. It's where you actually can apply the skill in a scenario. So we're looking at 3 different cities: Johnstown, Cooperstown, and Springfield, probably where Homer is located. So Johnstown, Cooperstown, and Springfield are all located in the order in a straight line on a highway. So if you're driving down the highway, you would approach Johnstown, then Cooperstown, then Springfield. So as you're driving, it's 12 miles from Johnstown to Cooperstown. Nice short drive. And a beautiful countryside as you drive through those 12 miles. Just beautiful. Colors are changing on the trees. It's just beautiful. Farmers, doing their farmer thing. Wonderful. Just, anyways. Then when you go from Cooperstown, or from Johnstown to Springfield, if you were to do the whole travel from Johnstown to Springfield, it's 95 miles. So that's even longer. Now, between Cooperstown and Springfield, there's not much to see. It's just plain woods you're driving through. You got to watch for deer. Oh, it's terrible. Anyways, what we need to do is we need to find the distance between Cooperstown and Springfield. So we know how far it is between Johnstown and Cooperstown, and we know what the total distance is between Johnstown and Springfield. Let's find out what that second part of the trip is between Cooperstown and Springfield. So to set this up, we're going to set up a equation with the information we know. So the way I set it up was 95 equals, and the reason I did that is 95 is our total number. It's going to equal 12 plus the variable I use is d for distance. The first leg of our trip is 12 miles, but what's the second part? Once we have it set up, we now just need to solve for the variable. So what do? First, look at the operation we have here, which is addition, right? What's the process we're going to use to get rid of the addition? If you said inverse operation, you're thinking like me, and I feel bad for you. Okay, inverse operation. So we subtract, because it says addition, we're going to subtract. So we subtract the number we do have, which is 12, and we do that to both sides. So we do 12 minus 12, which cancels out, and all we got left is d. So bring down d. And then we have 95 minus 12. Well, 5 minus 2 is 3. 9 minus 1 is 8. So that gives us the answer of 83. So how far is it from Cooperstown to Springfield? 83 miles. Make sure you write that down if you haven't yet before you move on. Now, just to kind of go back to this problem a little bit, some of you are probably going to look at it and go, well, I could have just done 95 minus 12, and that would have given me D. And you know what? You're right. You could have just done 95 minus 12. Because you see it that way, that means you're already identifying these numbers quickly in your head. It shows that you're strong in math. So if you are already seeing that process, good for you. So here's a second example. Pause the video, try it on your own, and then come back and we'll do it together. All right, so here we're looking at Patterson, Jacobsville, and East Valley. They're all located on another highway. So it's 17 miles from Patterson to Jacobsville and 35 miles all the way from Patterson to East Valley. So not as far of a drive, which is okay because this is a very industrial area and a lot of neighborhoods. And, you know, once you see one house and they're all pre-built, you've seen them all. I don't know where I come up with these stories. All right, moving on. So we have to find D for distance between Jacobsville and East Valley. So really we're trying to find what's the distance between here and here. So the way I set it up is 35 equals, because this is the total distance, 17 plus D. The first leg is 17 miles, but what's the second leg? We don't know. So we're going to have to, again, use inverse operation. And because we have addition, the opposite of addition is subtraction. So we're going to subtract 17 from both sides. When we subtract 17 from both sides, on the right side, we're just left with D equals. And 35 minus 17, well, We'll borrow from the 3 to make it a 2. And now the 5 becomes 15. 15 minus 7 is 8. 2 minus 1 is 1. So the total distance between Jacobsville and East Valley is 18 miles. Okay. Again, how can we check to make sure that's right? Do 35 equals 17 plus 18. We're basically taking D and we're putting 18 in for it. And it balances, nice and equal, so it is the correct answer. 18 miles from Jacobsville to East Valley. If you got that right, I want you to go find someone in the class and give them a high five. All right, you've made it to your box of thought. Congratulations. You should be proud of yourself. So go ahead and solve these two and then box it off. The first one says, tell whether the solution of C plus 4 equals 21 will be less than 21 or greater than. So it's trying to say, is the number that you're going to put in for C going to be larger than 21 or smaller than 21? Explain your answer. Basically saying if you understand inverse operation here. And then for the second question, it says describe how you could check your answer in example 2. So I just showed you the example 2 problem where we looked at the 3 cities. I showed you how to do the check. So make sure you can reiterate that you understand what we just did. If you have to rewind the video and watch how I checked my work, go ahead and do so. Oops. Well, okay, so you might have saw the answers. If not, that's okay. I still challenge you to try these on your own. If you're just writing down the answers because you saw them, are you really showing me you understand it? I want to see your work anyways when you show me your quiz. So when you come to show me your quiz, I want to see your work. I want to see that you did the inverse operation to all these problems. All right, you have 5 questions. Don't forget to label quiz when you're done. Come over to me and show me your work is done so I can give you your homework. And that's it for this lesson. We'll see you next time here on Math